All right, you guys, so we skipped, remember that you don't have a 28 or 29 on your paper because we haven't learned completing the square, right? So I'm gonna hop right to number 30 and 31, which say to solve by using the quadratic formula. So remember, this formula is on your formula chart, so you don't have to memorize it. But if you remember the little jingle, right, it's really great to remember it just because you're more likely to not make a mistake when you're plugging your numbers in if you know the formula versus, looking at a piece of paper back and forth. So anyway, your quadratic formula, oops, what happened to my highlighting? Anyway, okay. So your quadratic formula, remember, is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. There we go. So as long as you can figure out what the A's, B's, and C's are, which of course means it has to be in standard form, right, in order for you to use the quadratic formula. And so for number 30 is already in standard form. So all we need to do is pluck out the A, the B, and the C, right? So the A is the number in front of the x squared, the B is the number in front of the x, and the C is the constant at the end, right? So we know A is 2, B is -3, and C is -1. So now all we have to do is just plug those numbers into the quadratic formula, right? Oops. All right. Sorry, things are erasing as I tap on the thing. Okay, so here we go. X equals, now our first one, I'll put my big fraction bar, negative B, but B is already negative. So if I put a -3 in for B, I'm going to get -3. So that's going to be +3 plus or minus big square root B squared. Make sure you put it in parentheses. If you don't, you're not going to get the correct answer on your calculator. B squared minus 4 times A times C, all over 2 times A. So 2 times 2 in the denominator. So these are essentially your solutions, but just right now it's a big mess and you need to clean it up, right? And so right now, what you want to do is type all of this, which is called the discriminant. You want to type all of that in your calculator, right? So I always kind of like to do my second step. I like to do 3 plus or minus the square root of some number, which I'm going to put in my calculator in a second, all over 4, because 2 times 2 is 4. So that's kind of my little template for myself. So we're going to leave the square root because the chances of it being a perfect square are pretty slim most of the time. So I'm going to just type in my calculator, -3 squared, and you must put that in parentheses, minus 4, make sure you use the minus button and not the negative there, times 2 times -1. And when I type all that in my calculator, and you should do it too, make sure you know how to type things in correctly, I get 17. Now your third step is to simplify the radical if you can. If it's a perfect square, great. If it's not a perfect square, then you kind of want to do a factor tree on the side and see if you can simplify the radical. But 17 is a prime number, right? Remember, only 1 and 17 multiply to give us that. So 17 is prime, which means he cannot be simplified. So these are my answers, right? My answer is, remember, this is 2 solutions, 3 plus the root 17 over 4, and then 3 minus, right, using the minus sign, over 4. So I'm going to split that up and write it as 2 ordered pairs, right? So 3 plus the square root of 17 over 4, comma 0. And then, of course, 3 minus the square root of 17 over 4, comma 0. And I know those are pretty gross looking answers, but that's okay. Those are exact answers that keep me from having to round and have rounding error at the end. I'm just going to check this really quick on Desmos just to kind of show you, right? So if I go into Desmos and I just type in my function, 2x squared, oops, gotta have the x in there. Oh my gosh, I keep doing that. There we go. 2x squared minus 3x minus 1. Right, so there is our graph, and if I tap the x-intercepts or the solutions, right, I get those 2 numbers. Well, I'm just going to check what I got with our answers, right, because we've got 3, I like to do the divided by 4 first so I can create the fraction, then go up. Well, maybe, there we go. So 3 plus the square root of 17 over 4 was our first solution. And notice that tells me that it's approximately 1.781, right? And that is exactly what Desmos is telling me over here, right? So they totally match. And then obviously you don't have to check the other one necessarily, because if the first one matches, I'm sure you're good to go, right? But if I type in 3 minus the square root of 17 over 4, Desmos tells me that's negative 0.281, and that's exactly what it's telling me over here, right? So again, that took me, 10 seconds, 15 seconds to type all that in and just double check to make sure that I didn't make a silly mistake along the way with my quadratic formula, right? So it's totally worth that extra 10 to 15 seconds to check those problems, okay? All right, back to number 31. Now 31 looks great, but he's definitely not in standard form because all of our terms are not on the same side, right? So remember, we need all of our terms on the same side because our equation has to be set equal to 0. All right, so I'm going to move these guys to the right to join the x squared. If you want to subtract the x squared, that's fine too. So I'm going to subtract the 2x and subtract the 24. If you move your x squared over and make it negative x squared plus 2x plus 24 equals 0, you're still going to get the exact same answers for the solutions, right? So that's not going to have any effect. All right, I'm going to find my a, b, and c. My a is 1, since I kept the positive x squared on the right. My b is now negative 2, and my c is negative 24. All right, so here we go. X equals negative b, but again, b is already negative, so negative b would be negative 2, which would be positive 2, plus or minus square root, and then b squared, in parentheses, minus 4 times a times c, lots of stuff going on there, all over 2a, so 2 times 1. All right, and again, that's step number 1, just putting all the a's, b's, and c's in. Step number 2, I'm just going to bring down kind of like that same template, but I'm going to simplify my denominator to just a 2, and then I'm going to use my calculator to calculate what this number or this discriminant under the square root is. All right, so let's see, I'm going to type that in. Negative 2 squared minus 4 times 1. I'm typing it in my calculator exactly as it's written on my paper, parentheses and everything. And I'm getting 100. All right, which is awesome because 100 is a perfect square, right? So that means that radical can be simplified, right? Since the square root of 100 is 10. So we're going to write this as 2 plus or minus 10 over 2. So these are going to be nice friendly numbers because I don't have a square root anymore since it was a perfect square, right? But you still need to split it up, though, and do the plus and minus to get the 2 different answers. So here we go. I'm going to go through and do the plus sign. So 2 plus 10, which is 12. I'm going to write this out. So 12, but I still need to divide by 2, so that gives me 6. And then our other solution is going to be doing the exact same math problem all over again, but using the minus sign. So 2 minus 10, but now that's negative 8 divided by 2, which gives me negative 4. Which means our 2 solutions are 6, 0, and negative 4, 0. Writing them in as ordered pairs. Okay, and again, you can totally type that into Desmos, but you want to type in this guy. Oops. You want to type in this equation right after it's in standard form. Type it into Desmos and go check. Does it pass through 6 and negative 4? Right, it takes 5 seconds. Okay. I'm just going to write a little note over here on this one. Right, that's 17, right, cannot be simplified. Cannot be simplified because it's prime. There you go, just a little note there. Okay, Now let's go to this page where basically it's, well, we have, let's see, 4 on that one and then 4 on this page. All right, so the next 8 questions, oh my goodness, are solving each quadratic using any method except graphing, right? We don't want you using graphing because obviously that means Desmos is doing all the work for you. All right, so we want you either factoring, quadratic formula, or square root, okay? All right, so remember the only time you can use the square root method is if you have a single x term. This guy has 2 x terms, this guy has 2 x terms, this guy has 2 x terms, this guy has 2 x terms. So none of the problems on this page can I use the square root method, which means my only options are factoring or quadratic formula, okay? Now remember, you can only use the factoring method if it's factorable, right? And quadratic formula works 100% of the time. So you can kind of take that or leave it, all right, as whichever one you want to do. I'll kind of change it up a little bit here and see if things are factorable. On number 32, though, we need to move that 3x to the other side. So we're going to subtract it over, and I'm going to put them in the middle because I need my equation in standard form, right? ax squared plus bx plus c. Now, I might check to see if he's factorable, right, by setting up a little number puzzle and seeing if the numbers exist, right? Because if the numbers exist, then I can factor. If they don't, then I can do quadratic formula. Or you can do quadratic formula 100% of the time because it works all the time. All right, so on this one, we are looking for, let's see, there's an understood 1 in the front. So we're looking for the 2 numbers that multiply to give us negative 28. Put that over here. But combine to give us negative 3. So we want to see if those numbers exist. Well, 7 and 4 are going to work. And if we make the 7 negative and the 4 positive, that looks like our winner. So this guy is factorable, which is awesome. So I'm going to go ahead and factor this, which means I can split the 3x into negative 7x plus 4x, bring down my x squared and my minus 28. And so we were able to write him as a 4 term. And so now we can split it down the middle and just GCF, GCF, GCF. All right, so we can take the x out, x minus 7. We can take the 4 out, which also gives us x minus 7. Put my little smiley face because I have parentheses that are alike. So x minus 7 and x plus 4 is our factors. But we can't stop there because we need solutions, not just factors. So once we have it factored, we're going to set each one of those factors equal to 0 and then solve those little algebra equations, right? So obviously all I need to do here is add the 7, and all I need to do over here is subtract the 4 over. So that's going to give us x equals 7 and x equals negative 4, which we're going to write as 7, 0 and negative 4, 0. And of course, you would have gotten the exact same 2 answers if you did the quadratic formula, right? Which probably isn't any shorter than that factoring method, right? So, all right, on number 33, if I wanted to factor, I would be looking for the numbers that multiply to give me negative 1, but add to give me negative 4. And that clearly does not exist because the only 2 numbers that can multiply to give me 1 are 1 and 1, and there's no way that adds up to give me 4 in any way. So this guy is not factorable, right? Which means I have to do the quadratic formula, right? So here we go. So my A value is 1, my B value is negative 4, and my C value is negative 1. And then we just plug that into our formula. Here we go. X equals negative b, but b is already negative, so that makes it positive, plus or minus square root b squared minus 4ac all over 2a. So there's step 1. Step 2, I'm going to kind of write my little template down. Right, and 2 times 1 is 2, so now I'm going to go to my calculator, and I'm going to simplify all of that stuff underneath the parentheses. let's see, I'm going to negative 4 squared minus 4 times 1 times negative 1, and I'm getting 20. Now 20 is not a perfect square, so that means I need to simplify this square root if I can. So I'm going to go over here to 20 and make a little factor tree. I'm just going to start with 2 times 10. You can also start with 4 times 5 if you want. So, and then 10 breaks down into 2 and 5. So we can definitely simplify the radical because we have a pair of 2's. So that means we can rewrite the square root of 20 as 2 root 5. Right? Now I'm going to bring everything else down that was around that. So I'm going to bring down my 4 plus or minus, bring down my 2. And technically those are my 2 solutions. However, we always want to check to see if we can reduce. And remember, you're only allowed to reduce the numbers if all 3 numbers outside the radical have something in common, like have a GCF. If they don't, then you cannot do anything and you'd be done, right? And remember, you cannot touch the number inside the radical, right? It's like math prison. It's stuck inside that house, right? And so you can't touch him. So if 4, 2, and 2 are all reducible, then you can do that. And they are, right? Because obviously I can divide by 2 on all 3 of these. So if I divide 4 by 2, I get 2. 2 divided by 2 is 1. And this 2 divided by 2 would also give me 1. Right? So my actual final reduced answer is 2 plus or minus 1 square root 5, which I don't really have to write the 1 in the front, but you can if you want. And it's also technically over 1, which I also don't need to write. Right? You're more than welcome to if you want to, though. So all that just simplifies down to 2 plus or minus the square root of 5, which means our solutions are 2 plus the square root of 5, comma 0, and 2 minus the square root of 5, comma 0. And you could totally check that in Desmos, right? And then just type in 2 plus the square root of 5 and 2 minus the square root of 5 to see if those decimal answers match the decimal answers that Desmos is going to spit out. Okay. All right, here we go. Next one. We definitely need to bring the 3x over, and it's got to be put in the middle since he's the x term. So we're going to subtract the 3x over. All right, let's see. If I wanted to factor this, I'd be looking for factors of 28 that add to give me negative 3, and that does not exist, right? Because up here, you'll notice we did negative 28 that adds to give us negative 3, and those existed, but these are not going to. So we're going to use quadratic formula here, okay? And again, you can just use quadratic formula all the time when it says you have options and you can pick whatever you want. All right, so here we go. X equals negative b plus or minus square root of b squared minus 4ac, right, all over 2a. All right, so second step, I just kind of like to get my little template going, and I go ahead and multiply my denominator, my 2a, which is just going to give us 8. Then I'm going to go to my calculator. Oops, and type all this wonderfulness in to figure out what that number is underneath our square root. So here we go, negative 3 squared minus 4 times 4 times 7. And I'm getting negative 103. And that is a problem, right? Because if I try to take the square root of a negative 103, if you type that in your calculator, you're going to get an error. And you're going to get an error because in the real number system, we can't take the square root of a negative number, right? So this is not possible in the real number system. Because I can't square anything and get a negative, right? Because if I square any numbers, they always have to become positive. So there's no way I can take the square root of a negative number, which means my answer to this question is no real solutions. he does have solutions, but they don't exist in the real number system. They exist in the imaginary number system, which again, you'll learn about that in Algebra 2. So for now, our answer is just no real solutions. All right, let's look at number 35. If you want to check to see if it's factorable, right? We're looking for the numbers that multiply to give us 20, right? Let's see, 20, but add to give us -9. And I think that does work, -4 and -5, right? So this is totally factorable. So if you want to factor it, you totally can. I'm going to go ahead and just do quadratic formula though, because I like the quadratic formula and I think it's quicker, a little bit quicker than having to do the factoring method. So A equals 5, B equals -9, and C equals 4. Right, if you want to try doing the factoring method and see if we both get the same answers, that would be good too. All right, so let's see, x equals -b, but again, b is already negative. So weird that we keep getting negative b's everywhere. Then b squared minus 4 times 5 times 4, right? 4ac. Sorry, I'm going to move this over here. There we go. All right, all over 2a. So 2 times 5. All right, and I just do the same thing over and over and over again, right? I get my little template going here on step number 2. Go ahead and multiply my 2 times 5 in my denominator to get 10. And then I just go grab my calculator and I type all of that in to figure out what that single number underneath the radical actually is. So here we go, -9 squared minus 4 times 5 times 4. Oh, I'm getting 1. Right, which makes sense, right? We're getting 81 minus 80, so I get 1. And then we need to simplify the radical, and 1 is a perfect square. Perfect square, right? Obviously, 1 is 1 times 1, so we can take out a pair of 1s, right? So this is going to give us x equals 9 plus or minus 1 over 10. And then your job is to simply do the math there, right? So we're going to go through. We're going to do it once with the plus sign. So 9 plus 1, right, which is going to give us 10 over 10, which is 1. All right, so that gives us 1, 0. And then our other solution is x equals, let me go back through. I'm going to do the minus sign. Right, so 9 minus 1, which is 8, and 8 divided by 10, you can either write that as 4/5, right? Or if you want to write that as 0.8 as the decimal answer of 4/5, then that's totally fine too. That's what Desmos is going to tell you, right? Because Desmos only works in decimals and not fractions, right? So you can either write 4/5, comma 0, or if you want to write 0.8, comma 0, I would take either answer there. Okay, and again, a nice easy one for you to check on Desmos if you want to. All right, there's that page done. Now let's go look at the next page. It's the same instructions. Solve the quadratic using any method except graphing method. Let's go check to see if there's any we can do the square root method on. So remember, you can only use the square rooting method if it only has a single x term in the entire equation. So like this one has 2 x terms, so nope. This one over here, oh, he only has a single x. So we can use square root method on that one, and we want to. There's no other method we want to use on that because he's definitely not in standard form, and I certainly am not going to waste my time putting him in standard form because that would take like 6 steps by itself. All right, let's go down here. This guy has 2 x's, so nope. And this guy has 2 x's, so nope. So on this entire page, it looks like only number 37 can we use the square root method. I'm going to go ahead and do number 37. All right, so remember the square root method, right? Where basically, because it only has a single x term, we can just solve it like a normal algebra equation, right? Make that line a little straighter there. So we're just going to move everything to the other side and work our way towards the x to solve for x. All right, and you always want to work from the outside in, right? So we want to move the number furthest away first, which would be the -8. So we're going to move the +8 to the other side. Let's see, that gives us 2x minus 1 squared equals 20. Now we got to get rid of this 2 multiplier, right? We're working our way towards those parentheses. So we're going to divide by 2. So those cancel. So we're left with x minus 1 squared equals 10. Now we have to, in order to get to the x, right, we have to get rid of that square, right? So this is where we're going to square root. We did this earlier in the review under the square root section, right? So you can always go back and look at those if you need to, because square roots and squares cancel each other out, which is how I get to the x minus 1. I don't need the parentheses anymore, right? Because I don't have anything outside the parentheses anymore. And that's going to equal plus or minus. Now the square root of 10 is not a perfect square, and it only breaks down into 2 times 5 as his primes. So there's no pairs in 10. So that means I can't actually simplify the square root of 10, so he's just going to stay the square root of 10, right? And then lastly, I still have to get the x by itself, so I'm going to add the 1. And that is going to give me my 2 solutions. So x equals, now you can't actually add these together because they're not like terms, right? Get that off the screen. So I'm just going to put this little plus, this positive 1, I'm going to put him right in the front there because it would look really weird if I put him in the back. So it's much better if we write him in the front, right? So I'm going to write this as 1 plus or minus root 10. And those are my 2 answers. Right, so all you have to do is rewrite it in coordinate form. 1 plus root 10, if we go through and use the plus sign, comma 0, and 1 minus root 10, comma 0. And those are our 2 answers. Okay. All right. Let's go back to these guys really quick. Let's see. On this one, we definitely need to move this negative 16 over so that he's set equal to 0. So we're going to add the 16 to the other side. I'm going to go ahead and factor this one because there are factors of 16. You can do quadratic formula though. It works all the time. So there are factors of 16 that add to give us 10, right? And that would be 8 and 2. All right, so I'm just going to go ahead and do this one by factoring. So x squared plus 8x plus 2x plus 16. Right, I got it back to its 4 term. Then we split it down the middle and GCF, GCF, GCF 3 times in a row. So I take out an x, I take out a 2. I got my little happy face because my parentheses are identical. So I get x plus 8, x plus 2, but don't stop there because those are not solutions. Those are just factors. So to get our solutions, we set each one of those little factor equations, those linear factors, equal to 0. And then we just need to solve these little algebra equations, right, by getting the x by itself. So we're going to subtract the 8, and we're going to subtract the 2. And so that's going to give us x equals negative 8. And x equals negative 2, right? Which is going to, of course, be written as negative 8, 0 and negative 2, 0. Okay. All right, last 2 here on this page. Let me erase all these negatives. I'm just going to do quadratic formula on both of these. I actually think I have to because I don't think they're factorable just by looking at them. So, of course, we need to get that 11 to the other side. So x squared plus 8x minus 11 equals 0. So a is 1, b is 8, c is negative 11. Okay, so here we go. X equals negative b. Oh, finally a positive 8. All right, so when we put a positive 8 in the formula, right, it's a negative 8 plus or minus square root of b squared minus 4ac all over 2a, so 2 times 1. All right, I'm going to do the same thing I always do. Kind of set my little template up for step 2. Go ahead and multiply my 2 times 1, and then go ahead and grab my calculator and simplify all that stuff underneath the square root. Oops, I mistyped that. Negative 11. There we go. And I'm getting 108 for my discriminant underneath there. All right. Well, let's see. My next step is to simplify the radical. If it's a perfect square, great. If it's not, I need to see if I can simplify it using our little factor tree. And 108 is not a perfect square. So I am going to have to go off to the side over here and make myself a little factor tree for 108. Let's see. I'm just going to start with 2. And that gives me 54. And then I'm just going to do 2 again because these are all even numbers. So that's going to give us 27. Not even anymore, but 3 goes into him. 3 times 9. And then 9 is 3 times 3. All right, so he definitely has some pairs in there, right? We've got a pair of 2s and we have a pair of 3s. So that means when we're simplifying this radical, I can take out a 2 and a 3. They get multiplied together on the outside. And then, of course, this little 3 over here, he doesn't have a buddy, so he has to stay inside. Right? So that is us simplifying the square root of 108 to 6 root 3. And then I'm just going to bring everything else down. And then I want to see if it's reducible. And remember, the only way you can reduce any part of this is if all 3 numbers, and it has to be all 3 of them. You can't just do these 2, right? That doesn't work. Or you can't just do these 2. It has to be everybody or nobody. Okay, it has to be all 3 of them have to have a GCF. And these do, right? Because 8, 6, and 2 all have a 2 in common. So I can divide everybody by 2. So he's going to turn into a 4 or a negative 4. He's going to turn into a 3. And he's just going to turn into a 1, which I don't really need the 1 in the denominator. I don't need to write that. So my solutions are negative 4 plus or minus 3 root 3, which is the same answer. It's just the reduced version. And then, of course, I'm going to split that up, and I'm going to type it, or write it down as negative 4, oops, sorry about that, plus 3 root 3. That's one of my solutions, going through and using the plus sign. And then I go through again, and I use the minus sign in the middle, and that is our second solution. And again, you can totally check that in Desmos, but you would need to type those answers in and get the rounded decimal so you could check to see that Desmos was giving you the same answer. All right, here we go, number 39. Again, it's not set equal to 0, so I like to keep my x squared positive. That doesn't really matter for a quadratic formula, but I still like to just do that all the time anyway. So this is going to give me 3x squared. I'm going to subtract my 4x and subtract my 1 to move it to the other side. He's also not factorable, I can tell, because there's no factors of negative 3 that add to give me negative 4. So I am going to have to do quadratic formula. So A is 3, B is negative 4, C is negative 1. So here we go. X equals negative B, but B is already negative, so positive 4, plus or minus square root negative 4 squared minus 4 times 3 times negative 1, all over 2 times 3. And hopefully you're really getting used to quadratic formula and you're kind of liking it because it's really just the same steps over and over and over again, right? And so once you cut it down, right, it's a pretty comfortable method to use for most students to solve their quadratics. All right, so I'm going to get my little template set up and go ahead and multiply my 2 times 3. Then I'm going to go grab my calculator and I'm going to type all of that into my calculator and see what that discriminant is, that number underneath the radical. Oops. And I'm getting 28, which is not a perfect square. So that means it is my job to go over to the side and see if we can simplify the square root of 28. So are there any pairs in there? And there's definitely going to be pairs because 4 times 7 is 28. And I know 4 is a perfect square. That splits up into 2 and 2. Okay, so there's our factor tree, and we definitely have a pair of 2's. So that means I'm going to rewrite the square root of 28 as 2 root 7, because the 7 has to stay inside since he didn't buddy up. And then I'm going to bring everything else down. Okay, I'm going to scooch that down just a little bit. And then we want to check to see if it's reducible. So is there a GCF or a number that goes into 4, 2, and 6? Yes, there is, right? They're all reducible by 2. So I'm going to divide everybody by 2. That's just going to give me a 1, and this will turn into a 3. Which means when I write my final answer there, I get 2 plus or minus 1 root 7. So I can just write root 7. I don't need to put the 1 in front. It's understood to be there anyway. And then over 3. Right, and I know that's kind of a gross looking answer, but that's just how it works with quadratic formula if it's not factorable, right? So 2 plus root 7 divided by 3 is one of our answers, comma 0, and 2 minus root 7 divided by 3 is our second solution. And again, check it in Desmos. Right, you just got to type all those in. All right, I think I'm going to stop the video here because our next section is getting into like the quadratic regressions and all that and multiple choice and all that. So I will pick it up on number 40.